Welcome back, everybody from the break. It's my pleasure to introduce our next speaker of today, Arnout van Rijt. Arnout van Rijt is, well, as you can see, joining us remotely from the European University Institute in France, where he's a professor in sociology. He's also president of the International Network of Analytical Sociology and editor-in-chief of an open access, a well-known open access journal, Sociological Science. Arnout has done several studies, in particular with well, Matthew effects that are actually talked about earlier today as well. One particular problem with Matthew effects in general, so Matthew effects are, as you probably all know by now, is something that's a tendency to reinforce certain already existing inequalities. The typical problem with trying to infer these effects from data is that you always have something underlying the probability of, for example, citation. So Matthew effect is, for example, things that are already well cited accumulate even more citations, right? Or somebody who's already famous becomes even more famous. The problem is always that there's something underlying that is affecting the overall rate of accumulation of citations itself as well. Quality of a particular paper, research quality of a particular individual becoming more famous. All of these things are reinforcing each other, and that's well, difficult to sometimes infer that. And Arnout has done several field studies actually in trying to infer these effects from well, experimental interventions, trying to see whether these effects hold, and actually they do. So it is interesting that there's also this strong empirical evidence of these types of Matthew effects in several instances. And one particular other publication that he's been involved in is Matthew effect funding, where getting one grant helps you in getting the next grant. And this particular effect was demonstrated in Dutch funding data, in the case of the Dutch funding system. And now today he's going to talk more about, well, both this Matthew effect in funding, but also how it's related to peer review, and how funding proposals are being reviewed by several reviewers in different contexts of the proposals that are being reviewed. So without further ado, the floor or the screen is all yours.
Thank you, Vincent, for this great introduction. And also thank you and the organizing committee for giving me this podium and allowing me to share some of my work with you today. So here we go. Now I'm assuming that you see the proposal effect in science funding and on the big screen very clearly with my name under it. Okay, I'd hear no protest, so I assume that it's good.
1 second, I just messed up the pinning.
Oh. Then I will wait.
Yes, okay, now we got it. Sorry about that. So go ahead.
Yes, so yeah, today's presentation is about what we call a proposal effect. And this study that is still unpublished manuscript is basically part of a sequel. And the first study that preceded it is the study that Vincent in his introduction just mentioned, which is the Matthew effect in science funding. And the reason they kind of belong together, and I want to go over that first study today also first as by means of an introduction, is that second involves a field experiment that actually came out of the reactions and the way the first paper was perceived by the Dutch Science Foundation. They wanted to know more. And the second is that they look at the kind of the yin and yang of application processes. So on the one hand, where we evaluate two big things in science funding. One is the researcher good, and the other is the proposed research good. And to the extent that the research evaluated, there's the risk of a Matthew effect. But this is kind of counterbalanced against, if the research is good, then we might not necessarily need an established researcher to propose that. And so that gives the possibility that a famous researcher submits a crappy proposal and is not funded, and a not famous person submits a great proposal and is funded. And right, so our interest is in those two counterbalancing mechanisms. So let me give credit where credit is due, where the funding as well as the data come from the Dutch Science Foundation, and some of the funding also from the American Science Foundation. Co-authors, as mentioned, are Matthijs de Vaan, Thijs Bol on the first paper, and Muge Simsek and Matthijs de Vaan on the second paper. And I should especially emphasize the role that Thijs and Muge have played in the collection of the data, which was quite substantial. And technical support from Michael Claffey. Okay, so the Matthew effect. What is the Matthew effect? Well, Merton called it the accruing of greater increments of recognition for particular scientific contributions to scientists of considerable repute, and the withholding of such recognition from scientists who have not yet made their mark. And because of this perhaps unclear definition, the Matthew effect has taken on different meanings in the literature. So I think it's important to clarify what I mean by it in this presentation. And that is that there is a causal effect of success in the career of a scientist on the probability or the rate of another success happening in the career of that scientist. And our interest, of course, is in the macro level consequences that this has, or the dynamic consequences that this has, namely that you can have two similar scientists, A and B, one of which wins an award, the other not, then develop diverging career trajectories, where the initial success of the scientist becomes the impetus for further success, and thereby getting a successful trajectory and a less successful trajectory. And if the feedback effect is strong, perhaps this divergence continues far into the future, and we find people 15 years later, one has become a famous professor, another person has exited academia altogether and moved into industry. But is this really true? And as Vincent also alluded to in his introduction, the threat that is always lurking around the corner is that the scientists might look similar, but they really aren't that similar. And as long as we cannot perfectly measure how they are similar or different, it may simply be that the successes that we see unfold in the case of scientist A are the product of scientist A simply being different, better, more inspired, positively discriminated. Some other force outside of the Matthew effect is actually consistently generating successes for scientist A, but not scientist B. So how do you overcome that causal inference problem is a big part of the motivation for the first study. And past empirical support is actually weak for the Matthew effect. So you have, outside of academia where experimentation is more easy, typically the Matthew effect is confirmed, but then the effect sizes are quite modest and temporary. And that is important because, as we also later see, in order for success breeds success breeds success to produce divergence or increasing inequality effect, the Matthew effect needs to be very strong. So this questions how much of a driver of success differentiation in science the Matthew effect really is. And then studies within academia, in academia you cannot experiment so easily, so they have matched career award winners. But you take, for example, someone who wins the field medal, and then try to come up with other people who could have won the field medal but didn't, which is here the figure on the right. And then you find, for example, the strange finding that the medalists actually become less productive than the contenders. And then there's post hoc explanations for why that is. But here, if you can look at Clark medalists, another very senior famous award, where here this is cumulative citations. You see that compared to some synthetic control group, the winners of the medal subsequently become more cited than this control group, and that is consistent with the Matthew effect. Then here you have winners of an HHMI award. This is an American award, very prestigious. And this is the effect on the citation of articles that were published before they received the award. Right? Do they then suddenly get cited more? Well, yeah, I suppose, but then like one more per article, and that then disappears after a while. So really very minimal. So evidence is mixed and generally of modest magnitude. And so where we go is to say, well, is it perhaps the early career where much of this work is done, right? So if we are late in the career, we are comparing an established scientist with an established scientist who then won a famous award, but maybe a lot of the action has already happened at that stage. So what if we are in this more sensitive period, the early career? Is it perhaps then when a major resource is allocated to one scientist and not another that we can see this divergence more clearly happen, to such an extent that when we then look 10, 15, 20 years later, we do indeed see that one scientist become very successful and the other scientist not. Right, so we'll focus on the early career, and specifically what is so different there is that right here we find scholars who haven't established themselves yet. So this award can really make a difference. It's in a critical formative period, and it may also encourage the winner versus the non-winner to make career choices, right? For example, to stay in science versus exiting to business industry, or to be more ambitious in the scientific career. And so all these, we can see very powerful mechanisms driving the Matthew effect early on. And we look at this in the context of grant funding, and this, why in the context of grant funding? Because this is where we saw this opportunity for causal inference in a quasi-experimental design. And the hypothesis is that one grant leads to another grant, which was our definition of the Matthew effect applied to grants. Right? And what was our approach? What was this opportunity? It was a collaboration with the Dutch Science Foundation. We received access to the historical records of all the most applications, I should say, in a funding competition that up to this point now we're close to 3 billion, I believe, in funds that have been allocated through this funding mechanism. We have the evaluation scores and funding decisions for all grant proposals, not just those that got funded. And so what this gives rise to is a regression discontinuity design where we can compare the best losers, or non-winners perhaps, it's a better word, to the worst scoring winners, right? So in picture, it looks like this. Say you have a normalish distribution of proposal scores. The Dutch Science Foundation somewhere draws a line and says, "This, we have money for this, but not for this." Then you find scientists at either side of that funding threshold, but close to it. So these scientists are minimally different in quality of their proposal, as evaluated by the panel and the external evaluators, but they're maximally different in terms of whether they got funding or not. Right? One gets a large amount of money, the other gets nothing. So that is a situation that then allows us to disentangle the effect of the intrinsic quality of the scientists or the scientist's proposal from the awarding of the resource. Yeah, so some more details on the data that we used. This was the period 2000-2016 as these competitions ran. Initially, you only had a VD competition. Later, Feni and Vici were joined. These competitions differ a little bit. They involve many different sciences. Many of you will be familiar with this competition. There are one or more panels per division, 10 members each. We can talk about some of these details later if you're interested. Additionally, we merged into the data set subsequent funding achieved by these applicants in later competitions, including the ERC. So the starting grant for it, which is 1.5 million euros, the consolidated grant, which is 2 million euros, as well as publications, citations before and after the grant, which we merged from the Scopus database, as well as personal web pages of the applicants from which we derive their academic rank with some missing data problem in 2018. Okay, so what does the evaluation process look like? You first have a committee that selects strong proposals for external review. This is the pre-selection. This is where a lot of proposals already get filtered out. And in which the second stage, my second paper that I will be presenting, focuses on that pre-selection stage. Then external reviewers are invited for the remaining proposals, and the good ones are invited for an interview. And then after the interview, the committee assigns priority scores, and the top X above the threshold are funded. So our analysis strategy is to select these early funding competition committees up to 2008, so that we have enough future after 2008 to analyze as a dependent variable. And for each committee, we rank the interviewees by the final score. This allows us to pool the committees, so that we -1 here is the best scoring non-winner, and +1 is the worst scoring winner. And then we compare the later success of interviewees just above and below the funding threshold. Right. So here's the main result. The y-axis is the percentage of applicants who win a mid-career grant, which is the VD. Right. So the VD is for individuals who are 3 to 8 years past their PhD. The VENI is for 0 to 3 years. So this is the follow-up grant. What percentage of applicants in the VENI competition then later win a VD grant? And then the x-axis is, how close to the threshold you were. So -6 is far below or somewhat far below. +6 is somewhat far above. -1 and +1 are close to the threshold. And what you see is that there's absolutely a relationship between how you rank, right? So how well evaluated you were, and the percentage of, and the chances of winning a mid-career grant later on in the next competition. But that relationship is a threshold relationship, exactly around the funding threshold. So if you look left of the funding threshold, which is this vertical line, you see that there's no relationship. It doesn't matter how far below the funding threshold you fell, or how far above the funding threshold you fell. So the quality of the proposal, or the perceived quality of the proposal by the panel and the external reviewers, does not seem to matter. The only thing that matters is whether you fell above or below the funding threshold. Yeah, and then we evaluated the mechanisms. Here the evidence is not so strong, but nonetheless it provides some insight. So if you look before the competition and after the competition, you don't really see a discontinuity in citations, publications, age index, and nor do you see this afterwards. So what doesn't seem to be happening is that I win a VENI award that allows me to publish more or get cited more, and that then might be a mediating variable for winning a VD award. That's not apparently the mechanism. Now, this is not a proper mediation analysis, but the fact that there is no discontinuity here suggests that this is not the dominant mechanism. What does happen very clearly is that we find individuals who win the VENI awards more often among the applicants in the VD competition. So a piece of the mechanism of the Matthew effect is generated by this self-selection mechanism. How do we see this? Well, here again, we have the percentage of applicants applying for a mid-career grant as a function of their rank in the earlier career competition. And here we see a jump again. So there's perhaps a slight effect of ranks, so which is not unexpected. Yes, stronger scientists or strongly evaluated scientists might be more likely to expected to apply for a competitive grant. But the most what we clearly see is that there's a jump around the funding threshold, and so we go from roughly 40 to roughly 60% probability of applying for a VD grant. Well, in order to win a VD grant, you have to apply for it. So a piece of the effect is generated by the greater probability of being in the pile of applications for the VD competition to begin with. So a piece of the Matthew effect here is generated by selection. Now, how that selection happens exactly, we don't know. It could be that the Veni resources were used to write a better proposal, or it encouraged the applicants to write a better proposal, or it made more resources available, or they were encouraged by others. We don't know exactly why, but somehow it's an impetus that leads others to also apply for other grants. So one grant winning leads to applying for more grants. Okay, so the basic mechanism is, the basic dynamic is there, but what happens in the long term? Does it last? Because, and there's an interesting paper going back to the 1980s by Paul Ellison and colleagues in the American Sociological Review, which makes the case that, well, cumulative advantage, right, the success breeds success mechanism, does not imply increasing inequality in basic models of feedback. And up to that point, people had been assessing the existence of a Matthew effect in terms of the existence of growing inequality in a cohort. If you take a group of PhD students and you track them over time, and we see some become very successful and others not, when in the beginning they were mostly similar, that was the telltale sign. That was a smoking gun for Matthew effects. But Ellison all showed, no, that doesn't work. You can have cumulative advantage without increasing inequality. You can also have increasing inequality without cumulative advantage. So it doesn't really follow that that just because winning a Veni leads to winning a Vidi, we now get these diverging career trajectories. And you can, for example, it's a very simple model. You can see this. Like, let's say that the rate at which scientist A accumulates successes, grants, versus scientist B is some power function of that rate in the past, right? Then that coefficient, it determines whether this is going to produce increasing inequality. If F is greater than 1, then these are going to diverge. If F is smaller than 1, they're going to converge, and the career trajectories are going to come together, even though there is a self-reinforcing effect. The Polya-Earn model is the special case at F is 1. So it doesn't follow immediately at all that just because success breeds success, that is going to produce an ever-growing distinction between arbitrary winners and losers in these initial competitions. So it is definitely worthwhile to see if this lasts. And what we find is that when we fast forward a little further and people are now qualified for the Vici competition, we do see again that those who, now almost a decade back won a Veni grant are more likely to win a Vici grant. So at least at that stage, that distinction is still there. Of course, percentages are really low here because very few people last that long anyway. Okay. And what we did here is pull all those other grants from the ERC as well as the VD and the Vici and express the effect in terms of money, and then look over time what this divergence looks like. So the reds are the close but no cigar. These are people who were very close to winning the grant but didn't get it. Specifically, the solid red line are the -1, -2s. The +1, +2s are the solid green line. And again, what you see, there's no distinction among how far above or how far below the funding threshold you were. The amount of money you accumulate, this expressed in thousands of euros, does not diverge within or among these differently ranked people, except when you compare those above the threshold with those below the threshold. Then you see a gap appear that is more than double. And this gap does, with some creativity, seem to grow a bit, or at least it holds steady in relative terms. It doesn't shrink. This study, so this was published 4 years ago, and the question now is, what happened to these people? And 4 years after, this is still an interesting question to answer. And we have plans of extending the research with the data at hand and see if there is some convergence or further divergence in these careers. Yeah, and then you can look at how big of a gap is created. Well, it's big because this is the best ranked proposal. This is the worst ranked proposal. And these are the worst winner and the best non-winner. And so a big chunk of this total gap between the absolute worst applicant and the absolute best applicant is generated by the sort of chance event of falling on the right side of the threshold. So a big chunk of it is this arbitrary distinction that is just a function of the happenstance that there was enough money. Okay. And then finally, we can look at professor chances 10 to 16 years later. So what is the chance if back in the early 2000s, you won that Vani Award versus not won that Vani Award? What is the effect on when we now, this is 2018, we look at whether you are a professor or not? Then we see that that effect jumps from a little under 20 to roughly 30, perhaps a little under 30. So we still see the effect over a decade later, also not just in terms of funding, but also in terms of positional career success. Okay, so that was the first study. Clear evidence for a Matthew effect in the case of science funding, with some indications that this is happening through the classic mechanisms that a status, right? It's a signal of quality, it's a status effect, as well as resources, but then also kind of discovery of this other mechanism that people self-select into competitions, thereby increasing the likelihood of their success simply by being around, by being evaluated. And it's possible that people are aware of the Matthew effect. And all right, so think of science and science practice interfere with one another, and as a result, know that their chances are better and therefore are more likely to apply, and that only further aggravates the Matthew effect. So that was that earlier study, and NWO, I have to say, took this very seriously. Of course, we had many conversations with them. Right, this is them in publicly saying that they're aware. They're looking what they can do about it to address it. There have been changes to these procedures. The Matthew effect was mentioned, although I think in too positive a light in the NWO strategy 2019-2022. If you read this, it places a lot of emphasis on the positive sides of the Matthew effect. But nonetheless, there have been changes in the procedures. But of course, it's still the case that in these competitions, we also evaluate the profile of the researchers, and that weighs very heavily in the evaluation process, in the determination of who gets a grant and who doesn't get a grant. Another thing that NWO did was contact us and said, we want to know more about how this all works. And specifically, we want to know to what extent it matters that we consider a proposal in the first round of the evaluation process. So, right, a lot of people are already selected out very early when a few panelists on the panel make an initial call on whether there's any hope that this application is going to result in a grant. And is it useful? Does it matter if at that stage people even look at these proposals? Yeah, or are the decisions, if we made the decisions basically only on the basis of the CV of the applicant and perhaps a short summary of what they want to do, would we make the same initial pre-selection decisions? Right, and this gets us to the countervailing mechanism that might, provide still a decent level of merit in the system, right? Which is what we work also hard when we are writing proposals and evaluating proposals and advising people on how they write their proposal. If what we're doing is we're trying to come up with a means of recognizing good ideas and great science rather than just good people. So does this work? Right? So the business of grant proposal writing, we all know applicants spend a ton of time writing grants. Evaluators must then read those proposals, evaluate it. Panelists must meet in panel discussions. There are support officers, workshops, and books that advise on writing proposals. And then most grant proposals are not funded. So it's not a product. Of course, there's probably some idea generation in the process of writing a grant proposal, but it's to some extent, it's wasted once it's not funded, if it cannot be recycled. So all this effort, the point presumably is there is a proposal effect. It's a screening device. Without the proposals that we work so hard on to write and evaluate, the evaluators would end up funding inferior research than if they did, then when they do have those proposals, and that's why we have that. Right. So the question we asked in the study that we did with MWO was, if evaluators could not see applicants' proposals, right? You don't get access to the proposal text. You just see the CV and an abstract. Would they then select different recipients? In this case, would they then select different people to advance to the next round of the evaluation process? And that's what we mean by, is there a proposal effect, right? Does the proposal have an effect? And there are actually two reasons to doubt a large proposal effect. The first is, we know from the bibliometric literature that, for example, Borman and Leidersdorf, the proposal quality may be related, that is substantially related to CV strength. And this comes as no surprise. Yes, stronger scientists write better proposals on average. But of course, there will be variability. But to the extent that quality of the proposal is related to the strength of the CV, there's less of an opportunity for the proposal to make a difference. But presumably, to some extent, we can have a bad scientist write a great proposal, or not a bad scientist, someone lacking a reputation write a great proposal, and someone having a great proposal, a great reputation write a bad proposal. But what happens in the evaluation process in those cases, that is our second reason to doubt, namely if CV is still an imperfect proxy for proposal quality, and even if it is a bad proxy for proposal quality, evaluators might still use it, substitute it, right? Yeah, or at least take it as the glasses through which they are looking at the proposal through various mechanisms that are well established in the literature. Conformity, uncertainty, right? It's a lot of work, and then you still don't know if it's a good idea or not. And so it's reassuring when it's coming from an established scientist. And finally, panelists and reviewers often want to coordinate with others. They would like to pick the same person to advance. They don't like to deviate. And these are all mechanisms that might again lead the proposal evaluation to largely coincide with the CV evaluation. So we have a pre-registered hypothesis, which we have a number of them, but this is the main one. Two panelists who can both, and I'm providing a link to the pre-registration so you can look at this in detail. But we have a pre-registered hypothesis that was two panelists who can both see a proposal, agree on the merit of a grant application more so than two panelists of which only one can see the proposal. Now, why is this a good hypothesis? It's a good hypothesis, we thought, because, well, we cannot measure quality, right? It's in the eye of the beholder. But what we, at a minimum, can do is look if it matters, right? So say I am a panelist that sees the proposal and you're a panelist that doesn't see the proposal. Yeah. Now, we should disagree more with each other on this proposal because on the total application, because I have information that makes me change my mind. And it makes me adjust my evaluation. Whereas if we both have access to the proposal, then we should agree more with one another because we both have access to the same information. Now, and we thought it was a clever way to get at this, but then an anonymous reviewer in the review process, interestingly, pointed out, well, yeah, there's a little problem here, which is that you can also, if the variance changes, you can actually get, depending on how you're measuring agreement, you could get a smaller deviation or a larger deviation as a result of that effect. And so it doesn't necessarily mean what you think it might mean. And therefore, after we had pre-registered, we also wanted to test a different hypothesis. And at this point, I think we are convinced that this is the better way to do it. And that is the hypothesis that the odds that one application is better evaluated than some other application depends on whether the evaluators can see the proposal text. So now we're comparing a situation where we have two proposals, right? I rank both, and you rank both. Now, what is the chance that proposal one is going to be better evaluated than proposal two? That should depend on whether I can read the proposal or not. So if we both see the proposals, we're going to rank them more likely the same way than when I can read the proposals and you cannot read the proposals. And that's our second pre-registered hypothesis. And this doesn't suffer from this variance issue. Okay, and we can talk more about this. And during talks, I find it always hard to reason about this out loud. So I might have made a mistake in my interpretation of these things, but I think I got it right. But in the Q&A we can talk about these hypotheses. But we're testing both, so and the results are consistent, so there's no concern here. So the field experiment was conducted with the Dutch Science Foundation, right? The same program, in fact. Well, the VD program, so the same talent program, as it is called. Where grants are awarded to individuals. And NWO helped us organize, or actually organized for us, a shadow panel. This is a group of scientists who, parallelly to the actual evaluation process in 2018, also scored the proposals a second time around. This is a lot of work. And what we are interested in, we study only the pre-selection stage, right? So this is only the part of the process, that first step in the procedure where all proposals come in and we make a first selection. 160 applications, 43 panelists, but these are 43 additional panelists, those on the shadow panel, on top of the regular panel that already consists of many panelists. And there is bandwidth for 2 panelists per application. So each application in the shadow panel gets seen by 2 panelists, and then some more panelists also in the regular panel. So panelists were randomly assigned by us to either a proposal condition or a no proposal condition. So if you are a panelist in the shadow panel, one of these 43 panelists, then either you get a number of proposals from us with the task to evaluate them that are all in the proposal condition, meaning you can see all the proposals, or you're receiving applications of which you can only see the CV and a summary. So it's CV plus full proposal or CV plus only a summary. And here's the link to the pre-registration. Right, so this is what it looks like schematically. You have 8 regular panels, 8 shadow panels. Each 8, right? So these are different social science and humanities domains. Within the 8 shadow panels, we have 43 shadow panelists, and we have a block random assignment, meaning that within each of the panels, we randomly assign panelists to either the proposal or the no proposal condition. 21 get the proposal condition, 22 the no proposal condition. Then in terms of, right, the assignment to panelists is based on expertise. That is not random, done by NWO. Right, so what the NWO does is say, okay, you know, this is a panelist that has expertise on this particular application, so there's a better fit. Now, this fit is not always great because there's a limited number of panelists and a large variety of proposal topics, but there is some matching there. And the applications are scored naturally in 3 groups now, because either an application was reviewed by 2 panelists who were in the proposal condition, or 1 in the proposal and 1 in the no proposal, or neither was in the proposal condition. And you might think that this is supposed to be 80, but it's not correct. And we can talk about the combinatorics. So this is actually balanced. Yeah, So this is what the data look like. 319, that should be 320, but we lost one case because of missing data. 320, well, because we had 160 applications and each gets reviewed twice, so you should have, no, what am I saying? Yeah, you should have each twice. Because this is the regular panel, right? And this is the shadow panel. So we're double counting, so 320. Then we had, these are the 41 panelists, and these are the 58 panelists in the regular proposal. These would always have reviewed, but we additionally had these 41 people evaluate. How am I doing on time?
There's still, 5 to 10 minutes
For the presentation or also the Q&A?
for the presentation.
Okay, excellent, great. Okay, so I don't have to rush now. Okay, thank you. Yes, and to give you a very clear idea of what the data look like, they literally look like this. This is one of the 8 panels, CW. I think this is culturele wetenschappen. And there were 27 applications. There's no 24, and 4 panelists. These are the shadow panelists. Each application was assigned to 2 of them, and so you get, right? This is a combination of proposal and a no proposal condition, right? 3 and 4 were randomly assigned to the no proposal condition, and panelists 1 and 2 to the proposal condition. You also see that everything is anonymized, and that this data is we were not able to see identities, neither the panelists nor of the applicants. So NWO on their end did all this. We did the randomization, but they generated the data. So measuring disagreement was the dependent variable in the first hypothesis that was pre-registered. So what does this look like? Well, it's the absolute value of the difference between the score given by panelist 1 and panelist 2. These here, the scores are normalized within panelists. Yeah. Because some panelists have larger variance or are more positive in general. The results don't depend on whether you normalize or not, but NWO also normalizes. This is why we followed that. Because they try to filter out panelist specific effects in the evaluation. So here, for example, right, you would have a disagreement of 3.3 on application 1 because panelist 1 gives it a relatively negative score for panelist 1, whereas panelist 2 gives it a relatively high score. And so the difference is 3.3. Okay, so then the test results. So first the initial hypothesis. So we hypothesized that there would be less disagreement when both, I often screw this up, when both panelists can see the proposal, compared with when only one of the panelists can see the proposal. Yeah, because then there's an information difference. So if I leave out the proposal for one of us, then I shouldn't be, that should matter, but it leads us to disagree more. We don't find that. How do you see that in this table? Well, here's the mean level of agreement on the overall score. And there's also specific evaluations of the CV, of the proposal, and the knowledge utilization. And we can talk about those too, but we don't have time for that now, but we can talk about it in the Q&A. But let's focus on the overall evaluation. Doesn't matter here, there are also no differences except one incidental one somewhere. 0.87 for regular proposals. This is what normally happens. Then in the panel, pretty much the same, 0.85. Yeah. But if only one of the 2 shadow panelists sees the proposal, it goes up a little bit. This is in the direction hypothesized, but it's small and far from statistically significant. And when neither sees the proposal, they disagree also a bit more, but this is also, again, not statistically significant, this difference. And in magnitude, these differences are also small. So that's why little effect, of course, the power here is not great. So can we say it's absolutely zero? No. We simply can't, but it's not large enough and obvious enough for it to show up in this limited sample size study that we have here. So we conservatively conclude that there is no strong large proposal effect on this agreement. So what we see is it's pretty much the same when we both see the proposal. Then if one of us does not read the proposal, that doesn't lead the person who couldn't see that brilliant proposal but was looking at an otherwise pretty poor CV to suddenly change their score in the direction of the person who could read that great proposal. Right? We don't see that effect. Here's we did permutation test where we reassigned the proposals counterfactually. And then you see that it's in the middle of the distribution. Oh, did someone ask something?
Oh, no.
Oh, I heard something in the back. Okay. Yes, and then we do this in another way as well. What you're looking at here in panel A is the absolute difference in overall scores between shadow and regular panelists. So here you, and then comparing that distribution for shadow panelists in the no proposal condition versus shadow panelists in the proposal condition. So the degree to which the shadow panelists differ from the regular panelists, in absolute sense, does not vary with whether those shadow panelists could actually read the proposal or not. That's what you're looking at here, because these do not significantly differ, these distributions. And they very clearly, those disagreements are in the same order of magnitude. And here, this is the same thing, but then relative. This is why we have negative and positive values. And this is symmetric, and you see that perhaps there's a little bit more peakedness here. But the degree to which the shadow reevaluation of the regular panel differs from the regular panel does not vary by whether people in the panel, shadow panelists, had access to the proposal or could not read the proposal. So again, we conclude little effect on disagreement. Now, the non-pre-registered hypothesis is that there was little effect on re-ranking, right? So if you take a pair and you say, okay, which of these pairs is better ranked, then does it matter whether the people who ranked the proposals, the applications, could read the proposal or had only access to the CV and the summary, right? So we compared for any pair of applications reviewed by a shadow panelist in the no proposal condition, which of the two applications received a better score. And we computed how often panelists in the regular panels who evaluated the same pair of applications agreed. So I'm in the shadow panel, you're in the regular panel. I'm in a no proposal condition, so I can't see these proposals. I only read the summary and the CV. You are in the regular panel, so you do see the full proposal. How often do we agree on which of the two proposals is better? And the answer is 58.1% of the time. Now, that looks bad because 50% is pure chance, but it's not actually significantly worse than when I can also read the proposal, right? So the shadow panel, statistically already, the descriptives look very much the same, but they do not come to the same evaluations most of the time, the rankings. And this is also true if you permute within the regular panelists, because what they internally also don't agree with one another on the same proposals. And this replicates earlier research going back all the way back to the 1980s, that there is a significant role for chance in the evaluation of proposals. But what is of interest here is the degree to which these two differ, and they don't differ. because when we do this exercise, permute it, right, and then we don't find, we often find larger differences between these two percentages by random chance than we observe here. And so, but also in terms of magnitude, the degree of concordance is similar, right? 58 similar to 59.7. So withholding the proposal doesn't lead shadow panelists to come to a different conclusion, more so than if they also had access to the proposal. So I hope that this verbalization of these results was clear. So that leads me to the following conclusion. The proposal effect is small at best, at least in the pre-selection stage, right? So we spend a lot of time writing the proposals, evaluating the proposals, but at least in the pre-selection stage where panelists look at these applications for the first time, it doesn't seem to matter much in terms of who proceeds to the next round, whether panelists were even in the position to evaluate the proposal text. Right, so this casts doubt on the large investments in proposal writing and review producing a superior allocation of public funds, at least to the extent that the proposal text is used in the first stage of the screening process. And you can see how this is relevant for NWO policy and also how this relates to some changes that have been made in the procedures, including the format of the applications. Combining the two papers, right? And so now zooming out, right, with these two countervailing forces, Matthew effects perpetuating reputations. On the other hand, proposal effect may be counterbalancing, providing an opportunity for those with a weaker reputation to catch up, right? We find a strong Matthew effect that persists long into the future and that more than doubles the chances of winning another grant. But we found a weak proposal effect that we cannot statistically distinguish from zero, and a large role of chance, right? So if you zoom out, then what does the evaluation process look like? Well, it's basically past success plus chance plus maybe a little bit of quality, and that would then, in lots of models that you would build, provide make it possible for early career chance events not to be canceled out later by inverse luck, where the people who previously got lucky now get unlucky, but rather for that initial luck to be reinforced and produce successful scientists of very variable quality. And with that, I would like to finish today's talk, and I'm happy to discuss these studies with you and learn about your thoughts. Thank you very much.
Well, thank you very much for this interesting talk, Arnout. Are there any questions in the room?
Yeah, well, thank you very much. This is really an interesting presentation. I like your work a lot, and I look forward to seeing the publication or the preprint of it. It seems that you pile evidence on the existing pile we have already, that committees in their procedures for deciding on grant applications are not doing a really good job. The agreement is low, and ranking eligible for subsidy, that is, proposals, is not done well. It goes all over the place, and there are some convincing experiments already in the literature, like you alluded to. My question is, what conclusion should we draw from that? We recently, with 3 people, published a strong plea to introduce lottery in the process. And I think you will agree, but I'm not sure whether you agree, and that's my question. Do you agree that lottery, like we argue, will make it more fair, more efficient, and also more diverse, the process of grant allocation? What is your opinion on the thing?
I agree.
Wow.
Yeah, for precisely the reasons you spell out. Right. I mean, designing effective policy, we should be clear about, is an art, and it's right. So we were talking conceptually about lotteries. I mean, they're doing that properly, and there will be side effects. Of course, the application pool will be different, and so on. So how do you do this exactly is something that one has to think carefully about. But I think it's self-evident that it will have precisely these kinds of effects. And so why are we not already doing that? Well, to some, right? So indeed, there are funding agencies that do this, the Volkswagen Foundation. In Switzerland, they're experimenting with it. In Australia, New Zealand, they're doing this. I think it's increasingly being done. And it is clear that the evidence is convincing. It's inconceivable that it wouldn't have those effects. So yeah, I think one can have very little debate. I think a lot of the resistance comes from people who somehow have a belief that we human beings, right? There's no doubt here that that people are not trying to do a good job. That is not what we're claiming. It's just, I think scientists, put a number of scientists in the room and they can disagree on everything. It's just very hard to do this. And on top of that all, how well can we predict whether a study that we fund is actually going to advance science? I mean, I don't think we have much evidence on this, and to the extent that we have that, I think I think a lot of science is serendipitous, it's just a very hard thing to do. Now, so I mean, that doesn't mean there are, of course, aspects of, and I shouldn't talk too long about this because, we get into policy discussion. There are, of course, aspects of evaluation that are straightforward. I think that it is easy to find fundamental flaws in a proposal. So you could easily think of a bar that needs to be crossed in order for a proposal to be funded. And then once you're over that, so I think we can come up with a list of things that would absolutely disqualify a proposal. But once you're above that bar, right, how are you going to further differentiate? And I think we need to agree what the set of things is that on the basis of which proposals should be discarded, and then do a lottery among the remaining.
Just a very short follow-up question. The Swiss people, they use Bayesian ranking combined with lottery. Do you agree that that might be a promising way to go as well?
So I don't know exactly what Bayesian ranking is.
Okay, that takes too long. I hand over to this. Okay. But there's a nice preprint on it, and
I will read that. Thank you for suggesting that.
In addition to that proposal, or that the SNSF is using, that is also only ranking a particular part of, so it's not ranking all proposals, but only a particular subsection, just around the threshold that you've.
Yeah, you should weed out the ineligible and the seriously flawed application.
Yeah, so some things are definitely awarded, some things are not, and then there's a gray zone.
It's around the protection.
Only the gray zone that is being.
It seems to make sense.
Yeah.
Yeah, thank you for this very interesting presentation. I was wondering if the very inconsistent ranking applies to the CV part as well, if that emerges because people weigh the CV and the proposal differently.
It's a good question. So I don't have a result on that. I have to look back if we did this separately. We did this on the overall ranking because we were interested in what would actually have happened if NWO were to implement the shadow decisions. But I think the numbers in table 2 speak to your question, because you see that okay, so what we observe, and then we can see to what extent that answers your question. What we observe is that to the extent that there is any effect of our manipulation or our treatment, it happens in the CV. So if you compare here the proposal with the mix, see this difference is not far from statistically significant. The proposal doesn't, there's no greater agreement on the proposal, disagreement. In fact, it is reduced a bit, disagreements in the wrong direction. Knowledge utilization, no differences. But what you see here is a jump in the disagreement on the CV. So when one of the panelists does not see the proposal, then the two panelists will disagree more on the CV. Now, what that means, I don't know. It could also easily be an incidental finding because we do lots of comparisons here. but nonetheless. So I don't know to what extent that answers your question. But.
It's interesting that this effect is exactly counter to what at least my expectations would be. That's typically you would have the reputation of an author influencing the evaluation of the proposal. It seems to be completely reversed, that if they have access to the proposal itself, they agree more on the CV,
yep.
Which to me is sort of an, well, so perhaps indeed, as you say, it's a sort of a fluke finding, but nonetheless, it's it's remarkable that it's in this direction at least.
Yeah, I agree. We cannot really explain it. So I think the conservative interpretation is that there's simply no evidence for the opposite. Yeah, that's yeah.
Thanks. James.
Okay.
Sorry, wrestling with my glasses and mask here. Hi, Arnaud. Nice to see you. Great presentation. Just a couple of quick questions. So I thought, that from my perspective, this was one of the largest effects, certainly on future grants and full professorships. I was curious if other things like academic reproduction, like the number of students, that you advise or whatever was influenced. I expected it probably was. The second thing is I'm wondering if the small effect on publications in the future involves some kind of a trade-off with the relative attention to grant writing versus publications. And the third thing is I'm curious in the last experiment why you didn't set it up in the opposite direction. It seems much more intuitive that people would be more likely to anchor on CV than proposal. So I can imagine it being much less elastic, or I'm sorry, much more elastic if you had basically given them access to the proposal and then given them or not given them access to the CV, right? And this relates, for example, to Misha Teplitsky and colleagues' papers where they find, very strong likelihoods of updating as a function of their awareness of other simulated, Confederates grant, rankings of the same grants, as a function or partly as a function of the status of those other ranking individuals, not the ranked individuals. So it just seems I was just curious why you picked the design that you did rather than the converse. So
even though my eyes might appear large on the screen, I cannot actually see who everyone is. So is this Jim Evans?
Yeah, this is James.
Oh, yeah. Okay, yeah. So then I recognize your voice. I also don't know who were the people who answered the previous question. So so thank you for your comments, and but maybe I will learn this later after the talk. So 3 points. Let me see if I remember them properly. Let me start. Yeah, the first was, did you see other effects besides what I already showed you? So yeah, students that was not so easy to have data on. But I think it's implied by the fact that we see the professor chances increase a lot, and we see people get grants that are aimed at hiring personnel more. So it almost has to be the case that these individuals have more students that they work with, which may then accelerate or catalyze their careers in other ways, or hold them back. I don't know. Then the last point you made was about, why didn't we do the experiment the other way around? Yeah, I wanted to, but this is what they had decided they wanted to know at NWO, because I believe at the time they were wondering about the potential policy intervention. What if we select simply on CV in the first phase and ignore largely what the research idea is? That would save everybody a lot of time. And then people can submit. Of course, this happens elsewhere, right? Where you have very reduced proposals and then an expanded proposal later. I think that was the impetus partly. So yeah, I remember pushing for this, but we definitely would like to do it. And I agree that it is also plausible that indeed, as we were discussing this table, you would expect it to run more in the other direction. So if I can only see CV versus adding a proposal to it, now the CV is gonna be the glasses through which I look at the proposal. But if I can see the proposal with or without CV, then I'm not going to reinterpret the CV much more. I think this is your point, but something like that. But anyway, I think we would have learned a lot from that as well. But it's not what we were able to do here. But I do, again, I do think that what we're learning here is more about the why we're, as sociologists, we're interested in these out of control effects like the Matthew effect. But if we think about the rationality of the system, I think it's equally important to look at, and to what extent the striving for merit or recognition of good ideas or of talented scientists, to what extent that is working. And this, I suppose, this evidence is discouraging. And then your final point was at some trade-off, but I forgot what that trade-off was.
Trade-off with paper writing and grant writing. So you see a small effect in subsequent papers, you know, as a function of success at the cutoff.
Okay, so I win a grant and then I stop writing papers. Is that what you mean?
No, that I mean, you would have expected, I thought, I mean, you said that you would have expected a greater bump in the likelihood of producing papers published as a result of grants than you saw. And I'm wondering if that the small size of that effect was largely or could be accounted for by a trade-off in effort.
Yeah.
If you're not writing are you writing a paper? You know, so if you're and so this may not you know, influence in high, you know, capital intensive areas, but in areas that are not capital intensive and these are small grants, then these may be substantial trade-offs, right? So writing a grant may be exactly the amount of time or more than you would have spent writing the comparable paper, and so you don't see that bump.
That's an interesting idea. Thank you. Yeah, that is consistent with this figure indeed.
Okay, thanks.
Thank you.
One very last question. It's already 50. Short question, or are these all big questions?
Oh, no, absolutely, yes, please.
Okay, shall I then just leave it to to finish here? Thank you, Arnout, once again.
Thank you.